know it's quite late and it's raining outside and everyone now is seeking warmth. Everyone now is seeking energy. Energy. It's the main player for all decision makers across the globe nowadays. Energy is still the main mover and controller for all the worldwide leaders nowadays. So nothing will be better than securing a sustainable source of energy. Nothing will be better than turning a harmful waste into a sustainable and a green source of energy. So believe it or not, in 2024, more than 151 billion cubic meters of gas used to be burned across the globe without any necessity, producing more than 420 million tons of CO2 equivalent CO2 emissions. I guess now you're asking me a very important question. What can we do? But if you are asking this question in a reactive way, we are losing the power, we are losing the energy. As Mr. Stephen Covey has mentioned in his everlasting book, that if you are focusing all your mindset on the concern, you are losing your power. But if we adopted Mr. Einstein mindset, as he said, if I'm having 1 hour to solve a problem, I will be spending 5 minutes only thinking of the problem itself and only 55 minutes analyzing the problem itself. So if we adopted that mindset, we will be proactive. So the circle will turn to be like this. So instead of asking the question in a reactive way, we are going to ask it in a proactive way. We will leave the leaves and go down to the roots to analyze the problem. So we are going to define the flare itself. What is the flare? The flare itself, according to the ABI, is the system provided in a refinery or a petrochemical plant to ensure the safe and efficient disposal of pre-relieved gas liquids. According to the Canadians, it's the controlled burning of natural gas that cannot be processed for sale or any economic uses. So now we have identified the flare itself. Traveling to the Western Desert, where we had a case study of 1 million standard cubic feet per day of gas that used to be burned without any necessity, emitting more than 23,000 of equivalent CO2 tons per year and wasting 1.18 megawatts of power. To your surprise, at the same site, we had a gas compression station facility that was consuming approximately 1.5 megawatts of electricity. And if you are going to provide this electricity from a national grid or whatever source you are going to provide it, according to the sustainability factors, sustainability scope 2, you are still emitting CO2. So you will be emitting more than 7,000 tons per year. So in equivalent, we are wasting 2.68 megawatts. We are emitting more than 30,000 tons per year of equivalent CO2. And please focus on the numbers. 30,646 tons per year of equivalent CO2. In addition, we are losing money. This power would cost us $4.228 million every single year. And if you are familiar with the upstream facilities, if you are going to flare, you will also spend money. So approximately, we are spending $5,000 every single year. In combination, we are losing $4.233 million every single year. So we are losing money, we are wasting power, and what's more critical, we are harming the environment. With a capex of $4.2 million approximately, we have brought this flare recovery scheme to the site. As we have agreed together, we are going to adopt the mindset of being proactive. So we didn't accept this harmful impact as a fact. We have done something. So we have brought this gas basket to the site. The main components are electric heater, gas reduction, outlet lookout drum, piping and valves, steel structure, electricity and instrumentation work. These are the specifications of the skid itself. We are having an upstream design pressure of 92 bar gauges and downstream of 10 bar gauges. Maximum design temperature is 110 degrees Celsius with a capacity of 1.5 million standard cubic feet per day of gas. The dimensions is approximately 60 meters of length, 2.5 meters of width, and 3.5 meters of height. And the weight, the empty weight is 8.8 tons and 120 kilograms of PLC. So as a process engineer, I would like to share with you the plant process simulation. This is a simulation which I have crafted with my own hands in Bitrojet. These are the specifications for the LED stream. The main components of the plant, we are having separation and separators and production and separators. We are having the gas compression station. We also are having the filter, and we are having the flare recovery or the fuel conditioning skid. The fuel conditioning skid was able to produce these specifications to be matching with the requirement of the genset to produce the power. We also are having the lookout drum, we are having the ABI schema, and we are having 3 tanks and the capacity of 1,000 barrels per day of oil. So, the idea here, instead of flaring the 1 million scuff, we have brought the output of this fuel gas conditioning skid to run, to be as a fuel to the gas compressor station. So we have saved the 1.5 megawatts, but keep in mind that we are still providing this skid with some kind of power from the electric heater as a main component of the skid itself. So we are still consuming 0.038 megawatts of electric power. And also, with this electric heater, if you are going to provide this power, you are still emitting some kind of equivalent CO2, to be honest with you. It's approximately 260 tons every single year. So with these calculations, we were able, remember this number, we were able to cut, from this number, we were able to cut 30,386 tons per year. But we didn't stop to this limit. Let me share with you a process simulation of the fuel conditioning itself. Let's go deep. Let's focus on it. So this is a simulation of the flare recovery itself. This was the basic one. If you can see, we are having the filtration, the heater, and also we are having a heater for the oil stream. This heater was consuming 38 kilowatts, as we have said at the previous slide, and also emitting the 260 tons. We didn't stop to this limit. We have done some kind of value engineering improvement to relocate the heater to the upstream, which has a significant impact to lowering the power itself to be 229 kilowatts, which has a significant impact of lowering the emissions to be 200 tons per year. We have saved 60 tons per year. So also all the production going to be gas, which is also important. And the emissions, now we were able to, yes, let's go to the scale of power itself, to the scale of the power, electric power. According to the scale of the fuel conditioning scale, it's 20% saving of electric power. We go wider to the whole plant, we have saved 0.5% of electric power as an improvement. For the emissions, to the scale of the flare recovery skid, we have done some kind of improvement to the percentage of 23, and to the scale of the whole plant, 0.1%. Most of you are decision makers. I know that you need to know the cost. The running cost, we have fixed cost, we have saved 52,000 USD, and for the running cost, more than $7,000 every single year. So, to summarize, we had a 1 million scuff that used to be buried, emitting more than 23,000 tons per year, losing about 1.18 megawatts. At the same site, we had a facility that used to be consuming 1.5 megawatts of power. So we were emitting more than 30,646 tons per year for the equivalent CO2, losing about 2.68 megawatts. So, and also losing a cost $0.228 million every single year, in addition to $5,000 every single year for the flaring cost or at the flaring cost. We have provided the site with this flare recovery skid, which was able to produce these specifications. We got this power lost. We have also cut the emissions itself with a capex of 0.2. And this basic results were able to cut 30,386 tons per year. The capex were $0.23 million. As I have said, we didn't stop at this point. We have done some kind of improvement. It's summarized together the improvement results. We were able to cut 30,446 tons per year of equivalent CO2, saving about 2.67 megawatts, and the capex turned out to be $0.18 million. So we have saved money, we have saved power. What's more important, we have saved the environment for ourselves and the coming generations as well. I would like to acknowledge all the support of His Excellency, Engineer Walid Lotfi, the Chairman of Petrojet, and to all my managers, and to all of you for your kind attendance. Thank you so much.
Thank you, Engineer Mohamed, for your informative and live presentation. It's very well engaged and very always showcasing and changing case studies is very important, especially projects of flare gas reduction. This is real. This is existing opportunities that I do believe we cannot just stop waiting to start with it. It should be started right now because the value is there. These are all numbers, profits that are just lost, and I do believe that all operators should work on getting such low-hanging fruits. I'll open now the floor for any questions for Engineer Mohamed. Yes, please.
First, great presentation, thank you.
Yeah, so welcome.
I have a question about what if all the generated power is not required to site? This is a complex situation, by the way, for upstream companies. What's your, from your point of view, our solutions for this situation?
You mean that the flare is not power, right?
Yes.
You mean that the power doesn't need any electric power, so the plant doesn't need any electric power?
Yes.
So, you know, the flare recovery itself, it does have a lot of categories. You have the low pressure category, you have the high pressure category. This one is a high pressure category, and to our luck, luckily, the site has power consuming. But if we are having a low pressure one, what can we do? We will ask ourselves, what is the nearest facility that we can use? If you are having some kind of pipeline, we can compress the gas and compress it in a pipeline. This could be one of the solutions. If you are having a depleted wells, we can do some kind of injections. The gas itself can be injected as an uplifting. If you are having a requirement for the power, not so huge power, and I believe that any facility doesn't have a need for the power. The rotating equipment could be utilities, could be purging. We can use the gas itself for purging for any existing equipment. The compressor station itself, sometimes it needs to be shut down and have some kind of purge gas. Inert gas, we can use this gas itself to be for purging this equipment. We can use it also as a blanket, but with limitations, because for the tanks, if you are a process engineer, sometimes you are using the blanketing for the tanks. So according to the site and to the requirement of the client, what we do, we go to the client, we ask him for his needs and requirements, we do the analysis, and then we proceed.